Okay, this is day 10. We are still looking at the same data set that I shared with you. And to make it interesting, today we're going to upscale a bit and do some bit of predictions using machine learning. And the fact that we are almost in the middle of completing most of our learning path in data science, and we are now moving to machine learning. I believe that, with machine learning has two part. There's what we call supervised learning and unsupervised learning. But my main interest when it comes to machine learning, it's going to be focusing on creating modules. And those modules are the one which I'm going to be focusing on that will help me do a little bit of classification predictions. And of course, that is going to be my major focus. I've also shared with you the same data set. If you're going to use the Google Colab, like the Colab research.google, like the way I'm using it, the good thing is that you don't struggle so much about installing the libraries. The reason why I'm using it is because I'm going to just set up this machine over the weekend. Because yesterday I had a meeting, I couldn't get time to sort it out. Okay, but that doesn't stop us from learning. What is important is also how to input the source code. Then also on the other side, I sent you the work. I've not yet reviewed the source code that you uploaded on the GitHub. I'll do it today. I hope today is a Friday. That means I can have some time to look at the different um, tasks that have not been doing it. But I think I'll be very grateful now if I get done with all this kind of analysis, so that at least by next week, we'll be in August. We can do a little bit of more of 2 more examples with machine learning. And then we can start our last part, which is Python development, which is web development in Python using Django and Flask. And I should start preparing for you the data sets. I should start preparing for you the final project so that you can start working on it as early as possible. Yeah, your research actually ends in August. When we're done with August, so within the by mid-August, you should start working on your projects. So start preparing, because when August is done, that is it. You should have all your marks for this program. I don't want to push anything in September. And in fact, I'm going to try as much as possible to complete all this before 10th of August. As you're aware that I'm leaving the country, I think on 9th of August. So I'll try as much as possible to give you the project, I think next week. So that when I travel, I meet you guys online. Maybe when I'm back is when I will try to come to campus and see how you're doing the project. Maybe for the presentations, which are going to be physical. Okay, fingers crossed. Yeah, that's what I have to tell you. So I've given you the data set. We are supposed to do the same thing. The only problem is that when you use a Google Colab, if you don't save it, the source code keeps actually. Yeah, it clears. It doesn't save. It doesn't save the source code, so that's why I'm trying to redo mine. I'm trying to redo, which I know you already have this. So what I'm trying to do here, I don't want to again be writing the codes, yet we did this together. Okay. Then there are a few things I will keep mentioning it. I think I mentioned it enough, but I think next on Monday I will try to talk about it. So we could check for duplicates. Zero. Yes. We could check for null values. We had already finished this one, so I don't want to go back to it. Check for empty cells. We did that. We have checked for wrong format. There are no wrong format. Check for wrong data. Oh. um, Okay. But basically, I did because there are no wrong data. Okay. There are no wrong data. So let's now start the actual work here. Let's just start the actual work here. So what we are going to do, we are not going to do any bit of data cleaning because this data set that I've given you is actually, it's okay. You're not going to deal with like check null values, but all we can do, we can start on the exploratory data analysis. This one we can start with. And I'm not going to waste a lot of time. So just because we already know what you're doing, okay. So that's the exploratory data analysis. Now, we had even gone far with drawing the graphs. We were supposed to basically start from, we've done a lot of analysis. So we were supposed to start from, uh, let's just start from the pre-processing. You already have the source code with you. Okay. So let's try some bit of let's start with the pre-processing, which we actually did the other time. I remember we did some bit of pre-processing together. So let's do data pre-processing. And now here what we are interested in is to make the data ready for machine learning module. So let's uh, data pre-processing for machine learning module. Now, before we get to the actual machine learning module, we are basically going to do one thing, which we did. We're just going to do, allow me just do that because you already have it. Let me just create a visualization, okay? A correlation. Let's create a correlation, which you already have. So for creating correlation, I just want to do this, then we can move to the bit of machine learning. Let's create a variable. It could be C. I'm just trying to use C for correlation. Can use the data frame dot label dot as type. As type. Let's put them into category. Okay. So we will create the target. It's good to have the target data where you're training your data from. The target. Sure with what this thing is putting, so just have to be. Let's create the target as a dictionary that will enumerate the categories. Okay, that is perfect. Then we can do a data frame so that we can take in the target. Then you can have our Y to be the DF target. Then our X, use capital or small, that doesn't matter, which can be our DF, which is the data frame. And then what do we need? We're going to have the correlation between the nitrogen, the phosphorus, and then the potassium. Yeah, the potassium level. So let's do that by putting the column headers N for nitrogen. What we are basically showing here is that in our X and Y axis, we're going to look at the correlation between the two. And then let's do the P for phosphorus. Then the K for potassium. You can also do for temperature. They're just here up to rainfall. Temperature. And then we are going to do for humidity. We're going to do for pH, the soil pH level. Then the last one is going to be for the rainfall. Okay. So when I run this, it's basically just to prepare. Okay. No errors. Now we can try to get the correlation. Yeah, so like okay. So we're going to use if you don't have C bonds, then it's better you have the C bonds. Let's show this and see. Could improve this. Just improve this source code. Just improve here. That's dot for version method. Okay. Okay. So basically, this is to show us the correlation. Now, if I may ask you as a class, what do you depict from this correlation? Because to me, I can see that the phosphorus level and potassium level are highly correlated. When you look at the phosphorus level and the potassium level, this is what I'm talking about. When you look at the phosphorus level, which is P, yeah? And then you look at the potassium level, they're highly correlated. Why are they highly correlated? Uh, there's what they call positive correlation and negative correlation. So you see, on the other side, uh, high correlation is what? What's the value for high correlation? Hello?
One.
One. So
Yes.
when you look at phosphorus and you look at potassium, they're in this scale here, it's going towards one. That shows that there's high correlation. And what's the benefit of correlation? Why do we have to see the correlation level? Why is it important for us to use correlation?
Okay. For example, it helps us say if we have the phosphorus and then the potassium, like if the level of potassium increases, it means also the level of phosphorus will also increase. If it decreases, it will also decrease. I think that is what correlation does.
Okay, thank you. So I want you with the same knowledge. Let's try to, because you see, we're going to pick the machine learning module that we are going to use, especially since this is, we're going to use classification. And with classification, we can deal with common machine learning algorithms like KNN, which is the K nearest neighbor, so that we can see the correlation if it is closer to 1. Okay. Now, and then it will based on that to see which machine learning module works very well. Now, I want you to take a critical look before we start training our module. I want you to look at temperature and pH. What is the correlation between temperature and pH? What are the features of temperature and pH? Hello? What is the future of temperature and pH? Okay, to me, what I see is that still temperature and pH, there's what we call Guyson distribution. Their scaling is still between 0 and 1, with their minimum and maximum. When you look at the minimum scalar of temperature, it's still, it doesn't go to -1. It's still like it's in -0.2. Okay, so it is still between the minimum scalar of 0 and 1. So that would help us to understand how we can go ahead and look at the minimum scalar, and then we try to do a little bit of pre-processing. But we should always know that whenever we are trying to scale to set up all this module for training, we need to know which one is going to be our target data set and which one is going to be our trained data set. That is the most important thing. So we will try to split the data set so that we have some for training and some for testing the module. So the X will basically be for our test. We'll have X train and X test, and then we'll also have Y train and Y test. But our main target is to make sure that we split the data so that when we are trying to do our module, we have set some data for testing and then some data for training, based on the data set that we have. And the funny part is that this data set does not contain a lot of data. So our prediction, our module, when you look at the classification, might seems to be closer to 1. It shows that it will try to give us that impression of the good prediction, okay? But we should know that for a model to work very well, we need to train it on big data or large data. So the more the data, the better the module. Have you understood that? The more the data, the better the module. So let us try to let's try to deal with what we call setting the trained data set. And okay, let's just do machine learning modules. Train, set, train, and test data. Now, in most cases, if you're very familiar with what you do, uh, you could go ahead and try to get the percentage of those data that you want to train. Like the train module should be bigger, and then the test module should be smaller. Like in terms of 80-20, you could go ahead and do that. Is that okay? But for now, let us try our best to import first the module that will help us split the data. So you're going to go, wow, the good thing here is that okay, let me use that for now. Hmm? If you run into an error, I'll show you what to do. So what this one is trying to do basically is trying to get for you the scikit-learn, which is a machine learning module that will import the train split, which is going to basically split your test data to be 0.2. That means the remaining 0.8 of your data will be uh, will be used for training the module. But for this particular uh, module that I've been using, I realize one thing that whenever you, because you need to get the X train and X test, Y train and Y test. These are the variables that you're going to use for training your module. And then the test size of your data is going to be 0.2. You're going to do a random state of 42, but I don't think for this particular data, when you random state to 42, we'll have that. When we our correlation, our target is to make the data be trained in the scales between 0 to 1. So in most cases, I am going to change so that we when you're getting the classifiers for the predictions, it should not go beyond the random state of 0 to 1. We are going to get the minimum scaling and the maximum scaling. So for this particular module, that's what I'm going to do. But you can also use a random state of 42. So let's see if there's any error, we will double check. So let's now try to do some bit of pre-processing so that we get the minimum scalar and the maximum scalar. Okay? So we can say from scikit-learn dot pre-processing. You notice that I'm trying to ignore the Gemini Copilot that is trying to suggest for me. Because if I use it, because I've not been trying to train that model using that, I might run into what? An error. That's why I'm trying to rewrite the code. Okay. So we can have the minimum and maximum scalar. That's the only line of code that I need for now. Now what I'm going to do, since we have the X train and Y test, and we have also put our data so that we are training it on the test size of 20, which is 0.2. So let me reload this. Now, there's no error. Let's try to, let me add in one more thing. So what I'm going to do here, before even we look at our first machine learning module that we are going to use, I'm first going to create a scalar so that it can scale the minimum and the maximum. So I'm going to do a scalar as a variable and say minimum and maximum. Okay, this is okay. So minimum and maximum. Now, there is what we talked about transforming outliers. I remember Habwe asked us, how do you deal with outliers? Yes, we want to use a scalar so that we fit our module so that it knows our minimum value is -1 and our maximum value is actually 1. So we're going to use X-train scaled. Okay, we'll try to improve this a bit. So we will use the X-train. Let's create the variable to be called scaled, just to improve a bit. So that it takes in the scalar to fit the X-train data, the one we are training our module on. And then, since now we are done with that particular part, then we can try to, we are going to do the transformation, but I just want to comment for you this. We need to apply, I just put this comment for you to understand, apply the scaling, because when I explain, sometimes you may not get. Apply the scaling to the test set of our data. Test set of, apply the scaling to the test set as well. So that we compute for the training set. That's why you do this X-train. But since we use our scalar to be X-train scale, then it is important we also use our, we can rename this, doesn't matter, but let's just call it X-train scale. We are basically trying to scale so that we can have some data which are being fed into the module that are being used for our training. Now, when I run this, I don't expect anything to happen, but I just want to be sure that it has imported the machine learning modules and we have done the splitting of our data. Now, the only way we can now try to see how we can select our module is to go ahead, okay? Go ahead and do what we call selection. We can use confusion matrix, KNN, but for now, let's start with the KNN. So we can do selection of module. The module can be KNN. Which other module do you know in machine learning? Confusion matrix?
Random forest.
Yes, confusion matrix. We have also random forest. What else? Did you cover this with Mr. Livingston? The machine learning modules?
Not yet.
He has not mentioned them. Okay, I think he will mention them. Okay. So how about the SVM, which is kind of outdated? The support vector classifier. We can use classification like SVM. SVM is kind of outdated, but we will try to see if we can also try to use it. Now, we will also deal with what they call decision trees. I'm sure this is not very new to you. Decision tree. And then random forest. Random forest, of course, we have it. Okay. All right. So I think those are some of the machine learning modules that, but I know there are others, but for now, let's try to work with this. Then later I'll try to, I don't know if I'll do it later, module evaluation. I think next week I'll start to show you you how to use the F1 score, how to use precisions for your data. But for now, let's try to get the prediction. So now we are going to predict using KNN. And now when you're predicting using KNN, there's a tendency of this copilot, but I'm just going to try to ignore it from, okay, it's trying to get for me. It saves me with a bunch of typing. I don't need confusion matrix for now. For now, let me just work with only one. So it will have the KNN. The problem, okay, let me first press tab and see whether it will give me the prediction. See, I don't get any prediction. That's why I don't want to use it. Okay. Okay. Let me just try to rate for myself. So let me rate the k nearest neighbor. I'm not going to pass anything. That method. Then what I'm going to do is I'm going to fit the module. That should be okay. Then I need to get us. I need to get the KNN score on it for now. X test, Y test. Yeah. You give me the scores only for now.
Excuse me, sir.
Yes.
So is it possible for you to increase a bit on the font size? I'm not seeing clear.
Let me try to increase. Are you now seeing? Should be more visible.
Yes, yes. Thank you.
Okay. Okay. So let me try to explain something here. So what I'm interested right now is that I want to see the scores of this KNN module classifier in terms of the predictions. And because we decided to train our module basing on the temperature and pH, but this module is performing entirely for all our target data. So when you look at the prediction using the KNN, in terms of our correlation, the prediction is 0. What? Is 0.97. So 0.97, is that very accurate? Is that
Yeah,
very accurate?
0.97 is very accurate. That's okay.
Okay. So remember, we are also going to use a little bit of linear regression, where we are going to try to look at the linear accuracy using the support vector classifier. But for now, when you look at it, what impression does it give you in terms of the temperature and pH when it looks at this crop prediction? It's basically trying to show you the scaling the distribution of our module between 0 to 1, between the minimum to the maximum, it shows that this module is highly going to make a better prediction when you use the k nearest neighbor. But for us to understand this, we might be interested and first look at all the kind of, let's see. If we look at the data set, I don't know, let me just try to get back here and look at this data set. Okay, so I know it's kind of small, but when you look at the label, I want you to be very keen. When you look at this the label contains rice, maize, chickpea, kidney beans, and so on. Now, what we can try to do with confusion matrix, we can try to still use, we can try to look at all these scales, all these labels, how they can be correlated. And then we'll try to see if we can get better results, okay? And look at the different accuracy scores. So let us try to first visualize the entire label, which it's here. The title is just label.
When you press OK, it brings a bigger version of it.
Let me just try to, okay. Okay, guys, just know that we are trying to approach this data set. We're trying to understand this data set so that we can make the predictions for it. So first, we have done the prediction and we have seen that with KNN, we get 0.97. But can we have a better prediction that maybe goes beyond 0.7? Okay? Can we try to do that? Like we can try a different value so that we see whether we can get a better prediction. But we could also try to look at the correlation of all these labels and see, we have these labels that we have here. We have rice, we have maize, and we are going to use all this data. Let me just try all this data to get the correlations for it. It will incorporate all this data, and then we will visualize it using correlation. And then we try to see the correlation of these labels, so that we are using them labels, but these are crops, different crops. Is that okay? So if we can do that, then we can try to look at which one is more accurate using the KNN. And we can try to get maybe like range. We can try to use a for loop so that we get a range maybe like from 1 to 10, so that we see which one of these other ways can show us a better prediction. Which one will go beyond more than 0.7? Which one will have the highest accuracy in terms of the predictions? That's what I'm focusing on. So let's first try to do that using the, let's try to do that using let's just try. It's just with actually machine learning module, you keep trying one module and another and see which one works best. Okay? So let's try it with confusion matrix. Let's just try with confusion matrix. And the moment you put confusion matrix, that line of code will definitely know what you're trying to look at. And this variable to prediction, but I don't always prefer you, because now remember, if you press tab and try to run this, you look at what you're going to get. Okay. This is how it's trying to show you the confusion matrix. But you could improve it. You could improve your source code and get something which is kind of better. First, you need to get the matrix that imports confusion matrix. So you need to get that import scikit-learn matrix. Okay, that is still okay. Okay. So what I can do right now is that we can now try to still use the same way, X test and Y test, but I'll just have to modify this. Because I'm going to present it using the heat map. This is literally how it's supposed to look like, but let me just try to have a better look of it. So I'm just going to change this. Okay, doesn't matter, but Y predict. We'll always use the Y predict. Okay, just to make things better, let me just rewrite this. Confusion matrix Y predict. Okay. Then you can have a data frame of a confusion matrix. Okay, I think this is better. But I need to reduce on the figure size. To reduce on the figure size, I can use plt dot figure Okay. 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 Maybe I can first reduce a bit. Now, when I look at, okay, let me just try to explain the source code. So what we are interested here, like previously, the way we did with correlation visualization, we are trying to look at, we say that that phosphorus, the correlation between, we say that there was a high level correlation between phosphorus and potassium. So when you look at phosphorus and potassium, so the correlations are high. Now we also want to try to visualize it and see the correlation between all these other labels. So what we did, we created a variable and then we use a method, confusion matrix. Now, within the method confusion matrix, we pass in the y-test and KNN predict. And then the KNN predict method, we were able to use our test scale, which we created here. Now, we did a data frame for the confusion matrix to take in the data. Of course, pandas will read the data frame, and then we are trying to use ranges. The only difference here is that when we are trying to future scale it, we did not pass any value, but we were basically interested in looking at all these values in the range. That's why we try to iterate using the for loop so that it looks at it from all this staggered data to give us this kind of visualization. But when you look at the values which are here, 0, 0, 0, now, what impression does it give you? Because if you try to look at the k nearest neighbor using this same range, you are going to get a better, okay, you will try to see whether the results are going to be better in terms of the k nearest, in terms of the performance. Let's try to do it in this way. Let's try to look at the k range. Let's do a range of 1 to maybe 11. And then look at the scores. It's the same thing. It's still going to give us the scores, but we are going to use kind of we're going to use kind of a graph to try to we try to look at all the scores using a graph for us to see its accuracy. So scores, and then we can have, okay, let's see. So let's get the graph. Okay. This still some bit of time. Okay. This is not bad. So within a range of 1 to 10, when you look at the accuracy, especially on 4, it tries to give us a better prediction. Now, when we try to look at this graph here carefully, when you look at the accuracy is going towards 0.98. There's none which is above 0.98. So it's still a better score, but we've tried to look at the entire labels of the data. So now which one has the worst? Okay, not the worst, but the one which didn't perform well is this one. The accuracy is low on 7. Now, I'm going to make a conclusion. Don't worry about it. I'm going to make a conclusion. There's something I'm just first trying in and out here. Let me try to use the support vector, and then I'll give it to you in summary. Let's try to make a classification using support vector classifier from vector classifier. Let's see the variable to be linear. Print the first one is going to be okay. This should be able to do what I want. Okay. So when you look at the linear kernel accuracy based on this module, uh, using the support vector classifier, you see that it is 0.97. Don't worry, I'm going to make my conclusions. I'm still trying to make the predictions. Okay. Okay. Let me get it using another the SV. Poly. Poly. Okay, let's see. Should be able to give me also the poly accuracy, which is 0.8. Let's try to get using SVC using uh, exactly. The accuracy is 0 point. Okay. Just a second, I'm going to draw a conclusion here, basing on what I'm getting from these modules. I'm going to write the conclusions, don't worry. Um, okay. Let me just try to write for you the conclusion of this one, just for you to know. So the highlights are of this one. When you look at the linear, the poly, and the RBF kernel accuracy, you realize that which one has the highest? 7. It is the poly. So 1 poly kernel has a small margin accuracy score. Than the RBF. Because the poly is 0.988. So that means when you look at these parameters, when you do the fitting of the data, it shows you that in terms of the kernel accuracy, the kernel is the engine that computes the test run. It tries to show you that out of all these other support vector classifier, the poly is the one that has a better accuracy compared to the linear kernel accuracy and then the RBF kernel accuracy. Because here it can tell you from the output that we generated from training our module, you could clearly see that poly has 0.88 and RBF has 0.84. That means when you're trying to pick a module to use, the first module that we picked had an accuracy, which is the KNN, had an accuracy of 0.97. So if I tell you that which module works very well in terms of these predictions, for now, you're going to say it's the support vector classifier using what we call the polykernel accuracy. You could get a better prediction. But please note that we have not yet used also what? The decision tree. Let us try to classify, because this is a classification problem. Let us try to classify using another. Let's just try using another. Let's first get those classifier using decision tree. Okay. Still, you have to import the decision tree library from scikit-learn, import decision tree classifier. Okay. Now, You can run, it's okay. You could run this just to get the scores. Wow. Wow, this is amazing. Decision tree has the best accurate. Okay. Can we use let's use random forest. Then I can give you the final verdict. I'm just using those suggested so let's use classification using the random forest wow. For random forest is going to be
Excuse me, sir.
yes.
It seems we are too lost. We are not getting you anymore. We don't know what you are on right now.
You wait for the analysis report. I'm trying to get for you all the classifications accuracy. That's what I'm trying to do. There's nothing I'm trying to do which is so special. What I'm doing is I'm trying to look at the accuracy of the random forest, which is this one. You could see the results are here. I'm trying to look. No, you're getting lost because I'm trying to make sure that I compare all these machine learning modules. So what I'm trying to do here is basically I'm using the X-train and XY to train these modules. Don't worry, I'm going to repeat this for you using the simplest example. Because I've picked a data set that requires me to personally also analyze from this. So just be a little bit patient. I'm going to use a much easier example because I'm also trying to make sure that I look at the modules and see how best they work. Don't worry, I'm going to fix that. Okay. So with the random forest classifier, it is 0.997. This is 0.995. And then okay. Just a second, just be patient. I'm going to go back and start training you. Okay. When you look at all this data, this is 0.77, 0.997. Okay, let me now start again so that you don't get lost. Okay, all of you just get started from the start because you don't have any background in machine learning, so it's going to be a little bit confusing. So let's start with machine learning. Please listen attentive because I'm going to teach you machine learning. Then I'm going to teach you the type of regressions that are there. I'm going to teach you how to test and train the module step by step so that you don't get lost. Is that okay? So that you shouldn't be seeing stars here, but this is what you will be using. Okay. Now, let me start explaining. When it comes to analyzing data or dealing with data, we can split data into three categories. We can split um, we can split data into three categories. One, you could, in terms of numerical data, because I'm going to give you a project here, so I don't want to make sure you're. Then we are going to split data in terms of categorical data, and then ordinal. Then later I will come back to that source code and explain to you. But you will allow me extend with another 30 minutes. Now, when it comes to machine learning, data is supposed to be split in three categories. We have what we call numerical, we have what we call categorical, we have what we call ordinal data. Now, what is exactly numerical data? This is where you're getting lost from. Numerical data. What is numerical data? Now, numerical data are numbers that can be split into numerical categories. Okay? Numerical data are numbers that can be split into numerical categories. And this data can be in terms of discrete numbers or discrete data with limited integers. And then another one can be in terms of continuous data that is measured, especially like price or even the items. Then ordinal data are basically categorized or measured against grades. Like your score in any, even the test score that I've given you. If you get a score of 50, that means that is your score. So it is with ordinal data, they are measured against each other. So it can be your marks and a grade. That is what we call numerical data. Then there's another part which I'm now going to talk about in machine learning. There's what we call the mean, the median, and the mode. Now, when you're learning machine learning, it is important to apply the mathematical concepts like mean, which is the average value, median, which is the midpoint, and then mode is the value which occurred most. Now, we go to what we call standard deviation, okay? Now, when you come to standard deviation, we are now interested in looking at the variance, okay? The deviation of those data. Then you go to what we call the percentile, where you have to look at what? The statistics in terms of the percentages of those data. Now, then you come in terms of what we call data distribution. And when it comes to data distribution, you need to look at how data are being distributed. That's why when I come here to the accuracy and you're trying to get lost, is I'm trying to look at the data distribution here using machine learning, because this is a module. And before I reach here and I try to show you all this, all these things, I'm basically trying to look at data distribution, because we have so many categories of data that are there. We have what we call the nitrogen, phosphorus, potassium, temperature. Now I'm trying to look at all this data distribution, okay, in terms of the label. Now this label is that whenever you're trying to deal with data, you're supposed to look at the target data. And now since I'm also doing this particular analysis of this data set for the first time, I've not been like practicing it. I'm doing it, so I'm trying to make sure that whatever analysis that I'm using, whatever module that is going to predict using the different machine learning modules, I will only base on what we call the accuracy score of the modules. Now, when I look at this module in terms of using machine learning modules that we have what we call the KNN, which is the K nearest neighbor. So when I try to look at the score, basically there's nothing. These are just libraries. You don't need to cram. And basically we are looking at K nearest neighbor. Don't mind about this code. This code, you will get used to it. The first thing you need to do is to import the K nearest classifier that can give you the score prediction using the K nearest neighbor. And that score is what we have here, 0.95, where you're getting loss from. Now, I also tried using the confusion matrix, but because I needed to first look at my data distribution, that's why I decided to use the heat map. Basically, this is a heat map. We looked at how to put a heat map. That shouldn't be a big problem. So when I look at the data distribution, I was seeing 0, 1 here. And of course, this is where your technical experts come in to look at the distribution. Okay? Now, then I wanted to be sure if this distribution has better accuracy in terms of in terms of its accuracy in the range of 1 to 10. I use basically here just to get these ticks using the for loops in the range of 1 to 10. Basically, I'm plotting a range, which I use as a x-axis of k, with the accuracy. Now, the accuracy is basically between my minimum scale and the maximum scale. My minimum scale is -1. My maximum scale is 1. Now, that's why I'm trying, but it is showing me all the predictions here, all the accuracy are towards 0.98. Then I went ahead to confirm using what we call the support vector. You need to import the support vector machine and the support vector classifier. So when you import, you create, this is just a variable. And when you use the SVM, this becomes a method. What are you taking in? I'm taking in, basically I'm using kernel. Basically, I want to look at its kernel accuracy. That's why I was able to print out the kernel accuracy here, because I'm trying to compare and see. Because I looked at the distribution of the data and I look at the accuracy. So I'm trying to see here, the kernel, this kernel, which of the 3 kernels, which one is performing better in terms of accuracy? I look at the poly kernel, is the one which is giving me a better score of 0.98. Now I went and I tried to look at it using the decision tree, where you just import the decision tree classifier. You just create a variable. DT is basically decision tree. You could call it NA. Then you're trying to do what we call, they say the module may not perform well because of audio and imbalanced data. So I was trying to fit the module into that data, using that DF, fit the module into X and Y train. Now, which I'm going to explain briefly. Don't worry, I'm going to explain. Because I haven't explained it, I'm using it with an example. You're finding difficulties in understanding. So I was able to see that the decision tree is giving me an accuracy of 0.9. Now, of all this, what I'm trying to do is to compare the machine learning modules. Now, what I was going to say in my final conclusion, now when I use the random forest, actually the random forest gives me 0.997. Now, if I was to make my conclusion as a machine learning expert, of all this accuracy that you have been seeing, there is 0. I'm even going to ask you as a student, there is 0.0.98997, 0.995 using decision tree. And then 0.98. Okay, there's already 0.9, so there's none of this one. And then we also have what we call 0.7. Now, which machine learning module is good for making predictions among what we have tried here as a student? Tell me. I've not done anything complex. I'm coming to it. Test plate, and I'm going to come to it, and we're going to do it together. Which module is giving me the best accuracy? Just tell me from your own judgment. Let me not judge it for myself.
Random forest.
Which one is giving you?
Random forest.
Yes, it is random forest. Correct. So whatever I was trying to do all along, I was basically trying to look at which module is best for giving me a prediction. So stop there. We'll come back to that until you learn. Now let's go back to what we call distributions. Okay, there are several types of distributions that are there. You can use.
Excuse me, sir.
Yes.
Before we proceed, I want to ask a question.
Please go ahead.
About choosing the model. Like, doesn't it depend on the data set we are working on?
Of course, it depends on the data set. You see, like now, I picked this data set. I've never even tried to do any prediction on it. I'm just using my knowledge to see which machine learning module gives me the best accuracy. That was all what I was doing. So it depends on that data set. You may get a data set where the module you're going to pick to use may not even be random forest, may even be what? Decision what? Trees. And by the way, this is not how, this is basically to get the accuracy. But if I'm to teach you the actual way how you deal with decision trees, you know how to draw that tree diagram. You know that how to draw that tree diagram with branches.
Yes.
That's how you normally deal with decision tree. But don't worry, let me explain all of them until you understand. Because I'm sorry, I'm explaining machine learning module. I expected some of these concepts to be covered. They are not covered. Now, for the lady who asked questions, are you still okay? Because because machine learning module is an entire course of its own. But I'm trying to make sure that I fit the knowledge to you within the smallest possible time. Okay? Now, I'm explaining. I hope you're understanding. I'm not writing it down because of my time. Now, another thing which goes is that when you look at the distribution, there's what they call normal distribution, or there's what they call, especially the normal distribution, which you can use an histogram, okay? And then you plot that curve that shows the normal distribution, which we did in the previous example here. I don't know. You plot this kind of curve from the histogram. Now, is this a normal distribution in this age distribution, according to you? Is it a normal distribution? Hello? Hello? Are students there really?
That is
Hello?
not it's not a normal distribution.
Yes. So remember, I've explained these concepts. I talked about mean, standard deviation, percentile, then data distribution. Now, don't worry, we're about even to reach all those machine learning modules. Then, what type of distribution is this one? This is even not a normal distribution. So normally, I remember we had a graph which, yes. How about this one for temperature?
Yes.
Now, you see, the reason why we are trying to look at this distribution is for us to look at where our values are concentrated. Is that okay? So when you come here and you see me trying to plot maybe, even if a scatter plotter, this is a scatter plotter, I'm just trying to look at the accuracy distributions. Here, when I use correlation. But of course, if you go and talk to people, people will say, the best way to look at your data is to use what? To use a heat map, using correlation. It's the best way to visualize the data. That's why I was doing what? A heat map here. Now, don't worry, I'm going slowly. Now, so when you look at the type of distributions which are there, your focus should basically use histogram. You can draw that to get the what we call the normal distribution. Now, there's what we call a scatter plot. Okay? Now, a scatter plot is basically a diagram that helps you to look at the data that are represented in terms of dots. These are all machine learning what? Machine learning using what we call scatter plot. So you're basically using a diagram so that you can scatter maybe in the range of 1 to 10. I want to see how the distributions are in terms of the accuracy. Now, and you know this, the y-axis has the accuracy. The x-axis is basically contains a range of 1 to 10. So you look at the distribution. Now, I want to ask you, if you look at the dot, look at this one, which one do you think has a high accuracy from the dot points? Please, you be as an expert. Tell me which one has the highest accuracy. You did statistic. Don't waste my time. I have so many important things to explain. Which one has the better accuracy from the dots? The one above, right? Hello.
Yes.
Okay. Now, that's why you can use scatter plotter. For you to do scatter plotter, you need two values. You need the X value, you need the Y value. Okay? Now, if I give you, now maybe if that I don't need to show you, you will be able to plot that using, as long as you say plot.scatter, it will give you the scatter plotter. That shouldn't be something we should spend time on. Then now we get back into the actual thing which is called regression. I've not written it. Now I can start writing because now this is where I'm interested in. Guys, forgive me. I'm going to teach you machine learning module verbally. Then we will look at it using the codes because you guys have not covered this concept and you're getting confused. So let me mention all of them. So we are now looking at what we call linear regression. And you also did some bit of mathematics. Please keep referring to your maths. Now, what is the meaning of the word linear regression? Please help me, we go faster so that I look at the train test, we look at decision tree, confusion matrix. We explain all these machine learning things and get done with it. So that on Monday, we can get a full example, work on it from start up to the end without any problem. So what is regression? Okay, to save your time, regression is when you try to find the relationship between variables. So in machine learning, basically, when you're dealing with statistical modeling, the relationship is basically used to predict the future outcome. That is what we call regression. So linear regression basically uses the relationship between data points. And of course, in most cases, you draw a straight line in between it. So let's say we are going to get a linear regression here. How are you going to draw the line to show the regression? I think you are going to draw a line like this, right? Looking at the data distribution, right? Are we together? How are you going to? So you can draw a line like this to show regression. Guys, I don't need to teach you mathematics. Me, I'm supposed to teach you programming. But please just know that we are supposed to draw a line like this. If you look at this kind of scatter plotter. So that is how you try to look at the relationship. Okay, I'll try to, of course, these are the things we are supposed to be doing. Maybe can I give you one example of a graph? Then we draw it. We draw it using linear regression. Okay, I want you to be the one to draw it. I'm going to give you the values of X and the values of Y. Now, your X value is your X value is 5. Okay, just use that data. I don't want to waste a lot of time. Please, now, as a computer student, try to draw a linear regression. Okay? Now, this is where you come in. Since you have the two values there. First, because you're going to try maybe to use the matplotlib to do the plotting and so on. Now I could help you. I could help you and say you can import matplotlib. Now I don't know, some of you might even want me to still write the code of import matplotlib. Then from Skype import stats. Okay. Then Skype import stats. Perfect. Now, our intercept standard error, linear regression. X is not defined. Okay. Let me load that one. Okay. So basically what this one does, it will help you to get the slope, the inceptions, and then the standard error. Okay. So what I'm trying to do here is try and make it easier for you, for us even to what? Even to do a little bit of plotting. Okay. Basing on the data that we'll have. Now, we have the X, we have the Y. Now let's try to do it using this, just for demonstration. Now you see, this is the disadvantage with programming in the era of what? In the era of Copilot. I was supposed to write this code, but thank you. It has given me a function here that has a slope and x-intercepts. So module, let me just run, because my interest is just to show you. This is what I'm trying to show you using the same kind of data that we have. And this is how you get the plotting of this is what we call linear regression. You're getting it from the slope. So basically here, the reason why the line is passing through the points is based on our data. When you look at this data, looks like they're having all the increment of 10, 10, 10. This is when you add 10 to this, you get the value of Y. When you add 10 to this, you get the value of Y. When you add 10 to this X, you get that's why we are having this kind of. But if you try to change maybe you put, this time you put like maybe 20. Okay, reload this and then reload this. Now what happens to that point of value? That point of value moves away from the line. And of course, if all the points of these scatter plots are on the same line, and that is a perfect, it gives us a better prediction. You can confidently say that, okay, this prediction is actually very good, but it's very rare. On rare occasions, you will get it, especially if you're working with data. Have you understood what we call linear regression? There's now what we call polynomial regressions and then multiple regression. Should we look at polynomial regression? My target is to look at scale and test decision tree, confusion matrix, because that's where I confuse you. Any question to this point?
And we are confused the most, sir.
No, you're not going to be confused. Even when I look at how I'm supposed to handle you, I was supposed to start from the modules. And but have you tried to understand up to this point? First, forget about what I was doing. First, understand these basics of machine learning concepts. Have you understood them up to
And
this
that is
point?
the problem. We
No,
don't
Livingston is
understand
supposed to teach.
anything you are moving with.
Oh.
That's why you don't.
No, that's why I stopped. The thing is, Livingston is supposed to cover that part, up to that part where I talked about modules. And the reason why I want to concentrate on modules is where the actual training takes place. Now that
Excuse
Livingston
me,
has
sir,
not
let
covered
us
that,
go and listen to this resetting. Maybe we can understand.
but right now I'm repeating everything. Can I start again? It's okay, I can start again. As
No,
long as you understand the foundation.
no.
Mm.
Auntie, that is the problem. Maybe we begin from zero again.
But I started from zero. Can I repeat myself? Because if you don't understand this, then the module is actually the last bit of it. It's more, I agree. As a student, it is very hard to climb a tree. Start talking about confusion matrix, start talking about decision trees, start talking when you have not yet understood what machine learning is all about. When you even don't, even right now, I'm assessing you. Most of you have forgotten your mathematics of regression. If if I've given you values of X and Y, okay, now let me go ahead. We are not yet very far. I want you to try. You've seen how I was able to record, to draw this graph. Now I want to give you an example using the same thing, example. Okay? It is called now polynomial. We're going to spend time on machine learning. Okay, it's okay. I think it's my fault. I just have to admit that you guys have not yet studied machine learning and you cannot pick up this. So I need to teach you machine learning myself so that you can start understanding this. Because the test train, it is actually in the middle towards the end. Decision tree is towards the end. Okay, example, not example. Let me give you as an exercise. I know you will get it. Exercise. Plot a polynomial regression. Now, I am only going to give you the X and Y values. But please make sure you use scatter plotter to plot it. I'm going to be very simple here until you understand. So I'm giving you the values to be I'm going to, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 15. No? Okay. Then I'll try to I'm going to, you guys, you can't, okay, it's okay. I don't want to give you data and it's not what? It's not giving polynomial. Trello. Okay. Let me try to give you the values on the Y. Okay. So your exercise here is to plot a polynomial regression. Guys, regression is the first one. So let's start with regression. We have done what we call linear regression. Now we are going to polynomial regression. Then we are going to train and test, which I will explain that a little bit later. And then I'll give you time to look at this recording. Then I'll give you a data set that you will analyze using machine learning. So let's say that we are beginning afresh. Can you try this on your end and share with me so that I look at the kind of graph that you have? Then from there, I'm not going to talk about multiple regression. I'll just go and talk about scaling. And of course, that's where now you guys were not getting me. Just help me do that. Then we go straight to scaling. Then I talk about test and train. Then I talked about the type of machine learning which are there. And I leave you to rest. Then we start from there. Just plot for me a polynomial regression using this data. Can I stop sharing and you share your screen?
Yes, please.
Okay.
It is disabled.
Okay, you'll forgive me because I will be the one to. Okay. So you could now try to explain what you did.
Okay, so this is the data type, and I am using NumPy. So this method here, poly1D here, is used to make multiple, what do I call them? Multiple models. And then this one, my line here is, so I'm specifying here that I want to start drawing the line from 1 and then stop at 22, which basically are the starting point and the end point of the X values. And then this one is used to scatter the points. And this line here is used to draw the line through the points. And then we show the thing.
Okay, thank you. Any other person who wants to try? Yeah, that's a good one. That's the polynomial regression. Any other person who wants to try? Guys, I hear you. We're going to stop the lecture. Don't worry. In 1 minute. Now, what I want you to go and learn over this weekend, please. I know some of you want machine learning so badly. So we've started with regression. And now the next bit of it, which I just want you to go and learn, is to go and look at scaling. That's what I was doing today. Scaling, or you can call it future scaling. And then you need to go and look at train and test. Just look at it. Then after that, look at the machine learning task or problems. We have what we call decision tree. We have what we call confusion matrix. We have what we call logistic regression. Then we have, I'm just trying to give you all this so that you could basically go and try. We also have what we call random forest. We have what we call SVM, which is support vector machine. We have what we call KNN, the K nearest neighbor. Then we have what we call AUC, which is area under the curve. Then we have what we call the ROC, which is the receiver characters. And then you also need to try to learn something on the K-means. Now, that is what I want you to go and digest over this weekend. But for train and test, what you need to know is that train and test, you need to split some of your data set for training, some of it for testing. Yeah. Let me stop recording. Any question?